dear students, welcome back to the chemistry class. In the last class, we have discussed about rate of reaction, differential rate expressions, factors affecting on the rate of reaction, and concentration dependent rate. Now, in today's session, we'll discuss about rate expression and order of reaction. Rate law expression, or simply rate expression, or we can call it, or simply we can call it rate equation. Okay. Now, according to the law of mass actions, as you know that how to write the some rate expressions. But in order to predict the relation between rate and the concentration of particular reacting species, it is very essential to do some experiments. Based upon the experiments, we are going to determine the relation between the rate and its concentration of the particular reactant. So, according to that, so let us consider one hypothetical equations. Let us consider a hypothetical reaction. One reactions I am going to consider, that is A moles of A plus B moles of B plus C moles of C, which gives rise to the product. Okay. So in this case, according to the law of mass actions, so here we can write according to the law of mass action. According to the law of mass action, we can write the rate of this reaction is directly proportional to concentration of A to the power A, concentration of B to the power B, and concentration of C to the power C. That is product of concentration terms with some powers rise to this. That is, concentration terms are rise to the some powers which is equals to its stoichiometric coefficient according to law of mass action. Now, this proportionality symbol, if you remove, then it gives rate is equals to some rate constant, is known as rate constant or velocity constant, into concentration of A into concentration of B into concentration of C to the power A, B, C respectively. So where this K is known as rate expression. This is equation number 1. In this expression, the concentration of A, concentration of B, concentration of C, these three means individual concentration which affect the rate or speed or velocity of a reaction, which affecting on the rate. Along with stoichiometric coefficients, A, B, C, stoichiometric coefficient, we are not sure about that, whether it is directly proportional to its stoichiometric coefficients or not, whether it dependent, these stoichiometric coefficients, these power cell, these powers are equals to the stoichiometric coefficients or not. So in general, we can write rate is equals to K into concentration of A into concentration of B into concentration of C to the power some x, y, z or p, q, r. Also we consider it is a x, y, z, where this x, y, z, x may or may not be equals to stoichiometric coefficient A, b का power y है, b का stoichiometric coefficient यहाँ पर b है, this y may or may not be equals to the stoichiometric coefficient, z may or may not be equals to the stoichiometric coefficient C, may or may not be equal. So these values of this p, x, y, z can be determined experimentally. From the experiments we can determine the value of x, y, z. So therefore these concentrations which gives the rate of the reaction. So this expression is known as a rate equation or experimentally determined rate equation बोल सकते हैं इसको. Experimentally determined rate equation or simply rate law expression. Let us consider for particular some examples. Let's check few example consider करेंगे. Example number 1. NO2 plus F2. NO2 plus F2, this gives us to 2NO2F. So in this case, according to the law of mass action, we can write rate of this reaction is equals to K into concentration of NO2 to the power 2, because its stoichiometry is 2 to the power 2 into concentration of F2 to the power 1. तो ये इसका rate law हुआ. Now, but this 2 and 1 experimentally it is found that rate is equals to K into concentration of NO2 to the power 1 and concentration of F2 to the power 1. Look at this. According to law of mass action, simply by looking at the balanced equations, we can write it as a 2. But according to the experiments, its value is not is equals to 2, but instead of its value is equals to 1. That means it depends only on NO2 concentration, first power, not the second power. Equation देखो तो second power आना चाहिए, but experiment shows that its power is 1. So here, in order to write the rate law expression, it is very difficult. We cannot write simply by balancing the equation. It must be experimentally determined. तो ये पार्ट में some of the specific reaction को आपको याद रखना पड़ेगा, practice करना पड़ेगा. Just by looking at the reaction, balanced equations, you cannot write the rate law expression. From this rate law expressions, we are going to determine the order of reaction. So determination of finding the order of reaction in that part, order of reaction find करने के लिए आपको experimentally determined rate equation रहना चाहिए. Simple balance equation से जो law of mass action से हम लिखते हैं ना, ये equations नहीं चलेगा. So balance equation चाहिए. For example, और दूसरा example देखो. One more example. H2 plus Br2, this gives rise to 2HBr. Now according to law of mass action हम कैसे लिखते हैं? Rate is equals to K into concentration of H2 to the power 1 into concentration of Br2 to the power 1. Am I right? But experimentally determined rate equation क्या है? Rate is equals to K into हाइड्रोजन का पावर 1 है, बट हैलोजन का पावर क्या है? इट इज टू द पावर 1/2 है. दिस इज एक्सपेरिमेंटली डिटरमाइंड रेट इक्वेशन है. एक्सपेरिमेंटली डिटरमाइंड रेट ये है. इन दिस केस दिस वन इज एक्सपेरिमेंटली डिटरमाइंड रेट इक्वेशन है. तो एक्सपेरिमेंटली डिटरमाइंड रेट इक्वेशन है, एंड जस्ट बाय सिंपली राइटिंग अकॉर्डिंग टू लॉ ऑफ मास एक्शन दीस टू आर डिफरेंट. This one is perfect, experimentally determined rate. Let us consider one more example. Oxidation of bromide ion in the with bromate ions in the presence of acidic medium. This gives rise to Br2 plus H2O. 3 ऑक्सीजन है, 3 H2O, 6H plus 2 Br चाहिए, 2 Br. Okay. 3 molecules of Br2, तो ये 5 number of electrons का 6 plus चाहिए, तो 5 minus plus 1 minus. Okay, this is the balance equation. So according to the law of mass actions, you are going to write the rate expression as rate is equals to K into concentration of Br. Concentration of Br stoichiometry 5 है to the power 5 into concentration of BrO3 to the BrO3 minus to the power 1 है, Br minus, and into concentration of H plus to the power 6. I select up. But experiment shows that experimental determined rate equation which suggests that the rate is depends on concentration of Br minus to the power 1 concentration of BrO3 minus to the power 1 and the concentration of H plus to the power 2. So ये experimental determined rate equation है, experimentally determined rate equation. These equations are known as rate law expressions or rate equations. So therefore we can define as rate law, rate equation. उसका definition क्या है? Definition, rate equation is defined as, rate law or rate equation is defined as, it relates, it gives the quantitative relation between the rate of a reaction in terms of concentration of reactants with each term rise to some powers which may or may not be equals to stoichiometric coefficient. These are the mathematical expression which relates or which denotes rate of a reaction in terms of concentration terms with each term rise to the some powers which may or may not be equals to stoichiometric coefficient. Please note the definition. A rate equation, rate law expression definition क्या है? This rate law equation, the equation which denotes it is the mathematical expression. It is the mathematical expression or equation. It is the mathematical expression or equation. It is the mathematical expression or equation which denotes the relation between between rate of a reaction in terms of rate of a reaction with concentration of reactants with each term rise to some powers which may or may not be equals to stoichiometric coefficient in the balanced equation is known as a rate law expression. देखिए स्टेटमेंट देखिए यहाँ पर, this is an hypothetical reactions है, ये इक्वेशन, this equation is called as rate law expression. ये rate law expression से definition mathematical equation पे है. This is the mathematical expression which denotes the relation between rate of a reaction with concentration of reactants with each term rise to some powers which may or may not be equals to stoichiometric coefficient in the balanced chemical equation. This expression is known as, this mathematical expression is known as the rate law expression. Rate law expression. Or simply we can write rate equation. Is it clear? रेट इक्वेशन, ये जो रेट इक्वेशन है, रेट इक्वेशन लिखने के लिए बहुत डिफिकल्ट है. हम डायरेक्टली बैलेंस इक्वेशन देख के हम रेट एक्सप्रेशंस प्रेडिक्ट नहीं कर सकते यहाँ पर. इट मस्ट बी एक्सपेरिमेंटली डिटरमाइंड रहना चाहिए. तो इसके लिए ये जो रेट एक्सप्रेशन है, सम ऑफ द स्पेशल रिएक्शंस लाइक, अब देखिए कोई भी इक्वेशन देखे तो टू द पावर 1 टू द पावर 1 लिखते हैं हम, लेकिन ये पावर हाफ है, इसका पावर हाफ है. ये इक्वेशन में 2 NO2 बोले तो R2 कंपल्सरी हम 2 लिखते, लेकिन टू द पावर 2 नहीं 1 है. सिमिलरली डिकम्पोजिशन ऑफ एसिटाल्डिहाइड कंसीडर किया तो एसिटाल्डिहाइड CH3CHO इसका पावर 3/2 है, फ्रैक्शनल ऑर्डर. COCl2 कंसीडर किया तो इसका पावर भी 3/2 है. हैलोजन इवन इन सम केस Cl2 का भी पावर 1/2 है सम रिएक्शंस में. तो ये आपको याद रखना पड़ेगा. You need to remember the powers because it is experimentally determined. ये सब एक्सपेरिमेंट करने के बाद इसका आंसर्स दिया है वहां पर. So you need to remember the experimentally determined rate expression. Based upon this rate law expressions, we are going to define the order of reaction. The next heading is order of reaction. The next is order of reaction. The next heading is order of reaction. Note the next heading, order of reaction. Order of reaction. Order of reaction. Order of reaction. बहुत सिंपल है order of reaction definition. ये जो रेट एक्सप्रेशन है, यहाँ पर द पावर क्या है, x y z है, ये तीनों ऐड किया तो हो गया आपका ऑर्डर ऑफ रिएक्शन. क्या है, ऑर्डर ऑफ रिएक्शन इज नथिंग बट x plus y plus z in this expression. हुआ ऑर्डर ऑफ रिएक्शन. तो कैन बी डिफाइन, ऑर्डर ऑफ रिएक्शन कैन बी डिफाइंड एज sum of powers of concentration of reactants in a balanced chemical equation, in an experimentally determined rate equation. Order of reaction can be defined as it is the sum of powers to which concentration terms are raised in an experimentally determined rate equation or simply in a rate law expression is known as order of reaction. Order of reaction. तो इसका definition क्या है? इसका definition, one more time I am writing that for an hypothetical reactions A moles of A plus B moles of B, this gives rise to the product. एक reactions है, A reactions का rate is equals to K into concentration of A to the power X into concentration of B to the power Y. X and Y are the stoichiometric coefficients of A and B, which may or may not be equals to small a and b. So here order of reaction n, it is represented by n. Order of reaction is given by x plus y. X plus y is nothing but it is order of reaction. So in wordings definition कैसे लिखते इसका? Definition, order of reaction is defined as it is the sum of powers to which concentration of terms are raised. It is the sum of powers to which concentration terms are raised, concentration of reactant. क्या है definition यहाँ पर? Order of reaction is defined as it is the sum of powers to which the concentration terms are raised, concentration of reactants are raised in an experimentally determined rate equation. कंपल्सरी रहना चाहिए, it must be experimentally determined rate equation. हर एक इक्वेशन में देखिए अगर ऑर्डर ऑफ रिएक्शन प्रिडिक्ट करना है, आप ये इक्वेशन कंसीडर किया तो यहाँ पर 2 plus 1 3 आ जाएगा. ऑर्डर ऑफ रिएक्शन इन दिस केस इज 3, बट इट इज एक्सपेरिमेंटली डिटरमाइंड रेट कंसीडर किया तो 1 plus 1 दैट इज इक्वल्स टू 2. ऑर्डर ऑफ रिएक्शन वेरी होते हैं यहाँ पर. तो ऑर्डर ऑफ रिएक्शन डिफाइन करने के लिए the equation must be, the rate law equation must be experimentally determined रहना चाहिए. ये बहुत इंपॉर्टेंट है, नोट कीजिए क्योंकि ऑर्डर फाइंड द ऑर्डर ऑफ रिएक्शन बोल के क्वेश्चंस आते हैं आपको. The problems related to the order of reactions we'll discuss in the next class. Order of reaction, first of concept नोट कीजिए. ये हुआ definition. It's the sum of powers to which concentration of reactant terms are raised in an experimentally determined rate equation. ये हुआ आपका order of reaction का definition. Order of reaction. Yes. Next. Now, in this order of reaction, different types are there. First order, second order, zero order, fractional order, pseudo first order, etc. Order of reaction में बहुत सारे types है. वो types कौन सा है and how we are going to define. Let us explain. Okay, as you know that order of reaction order of reaction. In this order of reactions, it can be defined as sum of powers. Am I right? Sum of powers. So for this reaction, hypothetical reaction, A moles of A plus B moles of B plus C moles of C, this gives rise to product. So for this, rate equation is given by K into concentration of A into concentration of B into concentration of C to the power X, Y and Z, where the order of reaction is given by X plus Y plus Z. X plus Y plus Z. If this n value is equals to 1, it is called as first order reaction. First order reaction. If n is equal to 1, first order reaction. If n is equal to 2, second order reaction. If n is equal to 3, then it is third order reaction. If n is equal to 0, zero order reaction. If n is equal to some fraction रहा तो उसको हम क्या बोलते हैं? Fractional order reaction. Fractional order reaction. तो ये हुआ आपका first order reaction, second order reaction. तो first order reaction की definition क्या है? First order reactions is defined as the reactions in which the sum of powers of concentration terms of the reactant is equals to 1. Sum of powers of the concentration terms of the reactants is equals to 2. Second order. If the sum of powers of the concentration terms is equals to 3, third order. Sum of powers of the concentration term is equals to 4, fourth order. If it is equals to 0, zero order, or it may be fractional order reaction. Now, for each type, let us take one or two examples. Order of reactions का कुछ examples note कीजिए. First order reaction. Usually decomposition reactions are first order reaction. लेकिन हर एक reaction first order रहता बोल के नहीं. It must be experimental determined आना चाहिए. So let us consider one. Decomposition of ammonium nitrite NH4 NO2 nitrite ITE. If it decompose gives N2 plus 2H2 N2 plus 2H2, the NH4 NO2 to the power 1. NH4 NO2 to the power 1. So therefore order is equal to 1. Your first order reaction. Second one, decomposition of N2O5 nitrogen pentoxide gives rise to NO2 4NO2 plus O2. In this case, the rate of reaction is taken as experimentally determined. तो यहाँ पर 2 आते हैं. Stoichiometry देखे तो but experimental it suggests that it is equals to 1. Therefore order of reaction is equal to 1. First order reaction से. अब second order reaction consider किया तो second order reaction का एक दो example देखिए. Second order H2 plus I2 gives rise to 2HI H2 plus I2. तो इसका rate expression क्या है? Rate is equals to concentration of H2 to the power 1, concentration of I2 to the power of 1. Therefore order is equal to 1 plus 1, 2. Order of reaction is equals to 2. Order of reaction is equals to 2. Next, third order reaction. Third order reactions क्या है? 2NO2 plus 2NO2 plus F2. ये already example मैंने दिया है. 2NO2 plus F2 is a second order reaction. Second order reaction 2NO2 plus F2 gives rise to 2NO2F. In this case, the rate expression is given by rate is equals to concentration of NO2 to the power 1 into concentration of F2 to the power 1. Therefore, order of reaction is equals to 2. Second order reaction. Oxidation of nitric oxides NO2. Oxidation of NO2 gives rise to 2NO2 plus O2 gives rise to 2NO2. Order of reaction is given by rate expression क्या है इसका? Concentration of NO to the power 2, concentration of O2 to the power of 1. Therefore, order of reaction is equal to 2 plus 1, that is equals to 3. Order of reaction. Fractional order reaction. Fractional order reactions क्या है? H2 plus Br2 gives rise to HBr. So in this case, experimentally determined rate equation is K into concentration of H2 into Br2. Br2 to the power of half A is 1N. Therefore, N is equal to 1 plus 1 by 2, that is equal to 3 by 2 is the order of reaction. Second one is decomposition of CH3, CH2 acetaldehyde gives rise to CO plus methane, methane plus CO. In this case, the experiment shows that rate is depends upon 3 by 2 of CHO. The order is 3 by 2. So therefore, N is equals to 3 by 2. It is a fraction order reaction. And one more is zero order reaction. जीरो ऑर्डर रिएक्शन, ये देखिए जीरो ऑर्डर रिएक्शन कैसा फाइंड आउट करना है यहाँ पर. नेक्स्ट वन इज जीरो ऑर्डर रिएक्शन. ये जीरो ऑर्डर रिएक्शन का अगर एग्जांपल कंसीडर करना है, इन द प्रेजेंस ऑफ कैटलिस्ट बोल के ऐसा आपको आया तो इन प्रेजेंस ऑफ कैटलिस्ट N2 plus 3H2 formation of ammonia gives rise to 2NH3 formation of ammonia. So in the presence of platinum, अगर ये कैटलिस्ट नहीं है देन इट मस्ट बी इक्वल्स टू फोर्थ ऑर्डर आएगा. लेकिन कैटलिस्ट है, जब कैटलिस्ट है देन द रेट इज डिपेंड्स अपॉन ओनली कैटलिस्ट, नॉट ऑन द कंसंट्रेशन. द रेट इज mainly not only mainly depends on the catalyst. So therefore the rate of reaction is equals to rate of reaction, its order is equals to 0 because it depends upon the catalyst. H2 plus Cl2 in the presence of sunlight gives rise to 2HCl. Here it also depends upon the sunlight. Therefore, order of this reaction is equals to 0. तो ये find out करना बहुत आसान है. The reaction in the presence of some dash, in the presence बोल के अगर दिया तो आप वो zero order reaction में बोल के predict कर सकते हैं. So this is about the concept of order of reaction. So in the next class, we'll discuss about some of the numerical related to the order of reactions. Thank you.